Yeah, good evening everyone. So, it's the last speaker now. Feel happy? Okay, I hope that everyone's still awake. Yeah, I'm going to share part of my research, but I will make it general because the time is limited, so it's not details of findings or study. Okay, let's wait for the first slide. Okay, so again, I'm Yang Chia, or you can call me Avian with my nickname. I'm from Nilai University, Malaysia, and my field of study is mainly focused on nanotechnology or nanomaterials. So I'm going to share with you my talk with the topic, Small Tools, Big Research, Nanoparticles Transforming Science, Technology and Society. Okay, I believe most of you also know about nanoparticles or nanotechnologies, but when we say nano, okay, I briefly talk about here. So it's actually referring to the substance which is having the size 1 to 100 nanometers. Can you imagine how small or how tiny the nano size? Maybe we can take your hair, okay, one of your hairs only. Okay? So from one hair, you divide it into 10 million times. That's right, 10,000 times smaller. So it is definitely you cannot view with your naked eyes, but you have to take a special microscope, okay, TEM or SEM, then you can view something like this. Okay. Since they are very small size, normally they are in a powder form. From the physical look, you actually have a powder form, something like this. You don't think that a small dot of powder is referring to the nanoparticles, but the small dots of powder is actually referring to the agglomeration of all these, more than hundreds nano-sized particles. So it's very, very small. But these tiny particles, they are very powerful. Here I highlighted 4 special and unique properties of them. Okay. First one, they have enhanced catalytic activities. For example, gold nanoparticles, there is excellent catalyst only at nanoscale. If it's a bulk gold, yeah, everyone loves it. Okay? And the price is increased drastically recently. Okay? But if they are in nano size, they are extremely excellent catalysts. Okay? And also, they're having a photocatalytic properties. For example, titanium dioxide and zinc oxide. Okay? They always produce the electron-hole pairs under the irradiation of light. Okay. Then also they have a mechanical strength improved so much. For example, the carbon nanotubes and also nano diamonds. Okay, they are extremely strong. And not forget, they also have electrical and magnetic strength improvement. In this case, they are very useful in the semiconductor nanoparticles. Okay, they can change the colors, energy levels, and even the energy gap. Okay, let's see what are the applications of nanoparticles. Okay, since we have many healthcare experts over here today, so begins with the healthcare. I believe some of the speakers also mentioned just now, like this morning, Dr. Ravi mentioned about the medicine delivery system using the capsule, so that is also in nano size. Okay, over here also I would like to highlight, okay, especially in the drug delivery system, okay, they are moving towards the nano size. And also in the MRI or CT scans, they're also using the technology based on the nanoparticles. Okay. And not forget, we have nano carriers in the cancer therapy. Okay. And we have this one vaccine, also nanoparticles based, which is mRNA and also LNP. And additionally, nano antibiotics and also wound healing gels, also in nano size. Okay, here I highlighted 3 of them, like I mentioned just now. Sorry, can you please go back to 2 slides? Yes, thank you. Okay, so this one, MRI, they're based on the changes of the colors or energy, okay, to detect different colors change, and then they can diagnose. moving this one future study. We have a smart nanoparticles for cancer therapy, and over here this system is including the drugs delivery system as I mentioned just now, and also quite similar to Dr. Ravi study in this morning. Okay, they use the nano-size capsules, or mainly made of liposome or also polymeric. So they putting the drugs inside and let it flow through the bloodstream, and reach the targeted cell and release. So this is a very high percentage that the patient can get the treatment. Okay, not forget also these nanoparticles also very useful in the environmental treatment, okay, especially in the pollution. They can treat based on the photocatalytic degradation, and also absorb the heavy metal which is very toxic if entered to our body, and also the water treatment, and not forget the air purification, which is very useful during the pandemic COVID-19 time. They use the nanoparticles to make the air purification system, and also make the, for example, the nano silver, they put it in this textile to make the mask. So that is very useful. Okay, over here, this figure highlighted two different nanoparticles for the organic and inorganic, and also they are showing the antiviral function. Okay. Nanoparticles also very useful in energy and technology application. As I mentioned just now, the MRI is like overlapping or cross-disciplinary, because it's also applied in the medical, and then also is actually related to the semiconductor or energy. Okay, other than that, nanoparticles also can make the solar cell, okay, and also high performance battery. Nowadays, many our vehicles moving towards this hybrid system or the EV. So that is the battery that make use of the nanoparticles. Okay, and also hydrogen fuel catalyst. They added the nanoparticles in the fuel to have a catalyst and enhance the properties of the fuel. Okay, so these are the examples where the solar cells, okay, the dyes in the side solar cells, make use the titanium dioxide and zinc oxide, okay, over here, to have a better function of this one solar cell or solar battery. Okay, in horticulture, okay, yeah, I believe just now Dr. Kartiyan mentioned the entomology. So yeah, we have a pesticide to kill all these, unwanted bugs. Okay. So other than that, yeah, I just show you this summary by referring to this figure. You can see the nanoparticles can improve crop improvement based on the transgenic plant, and also they can have protection for the crop using the nanopesticide, and the precision farming. So they use the system to detect. Then it's more accurate and higher productivity. Okay. Then also they can detect the stress tolerance, and also based on the nanomaterials, they can have cells enhancement in between the soil and all that. Okay. And it helps the productivity, because the plant will grow much better. Okay. So if you are not in healthcare, if you are not in agriculture, you are not in energy, you feel that nanoparticles is not related to you, but no. Okay, let me ask you one question. You brush your teeth daily? Yes, right. Okay, yes means at least all of us in this room, okay, we may use at least one or two products daily which consisted nanoparticles, because when you're brushing teeth, you use the toothpaste, also consisted nanoparticles, titanium dioxide especially. And for ladies, you apply sunscreen, cosmetic, they are also having titanium dioxide or maybe zinc oxide. Okay? So we are not too far. So even including the self-cleaning coating, maybe nowadays the windscreen also, they apply this self-cleaning function, which is also consisted of nanoparticles. And yeah, the food packaging. Because they want to have an antimicrobial function, they also inserted slightly dose of the nanoparticles. Yeah, this tiny tools very powerful, but yet because of their nano size, we also will have risks. Since they are too small, maybe they will have a seepage or they are easily, linkage. So that's why we must also take the safety guidance by the regulatory, limit the dose usage. But all of us as a researcher, we actually love this risk because of the risk, then only we will have problem statement, we have research data. Okay, so I feel that with this nanotechnology, nanoparticles, nanomaterials, our research and study will not end. Okay? But however, we have to also include our ethical when doing this research. So based on the risk, safety, and ethical, combining these three, I believe these nanoparticles will have non-stop and you have a futuristic study again. Yeah, so including like recently, the study have a smart nano robots. Okay, they let in this small robots enter to the body to detect what is the problem or condition of the body. Okay, then also personalized nano medicine. Also, we have now today famous with AI. We have AI-driven nanomaterials design, and moving towards the sustainability, we will synthesize the nanoparticle with green synthesis method. So all these are the recent and future direction of nanoparticles. So come to the end, summary of my talk. We can see from this general discussion, the nanoparticles is offer cross-disciplinary benefits. Okay, I believe all of us in this room, no matter what field you are, okay, you can find a way to apply nanoparticles. Okay, and then that, as I discussed with you just now, the transformative application in many fields. So I believe ongoing research and global interest will capture, and that's why I want to take this opportunity, to let you save my number and contact me. Okay, if we can have a further collaboration or maybe non-stop or future collaboration, then please contact me. And if you are not interested in nanotechnology, also doesn't matter, because since I'm the head for research department, I can find a suitable researcher to collaborate with you. Okay, thank you. So come to the end. Okay, on behalf of all the participants for today in this very wonderful and meaningful event, annual summit and awards, which organized by the Venus International Foundation, the organizing teams. Thank you very much for this nice arrangement, especially the chairman, Dr. Satish Kumar, the program chair, Mr. Sudha, and also other team members. So we would like to thank you all.